Okay, we got Advent of Code Day 12. Let's see how this goes. Using a different setup today, so it might be a little slow. Let's get our puzzle input. And it looks like we've got letters plus numbers. So we're going to say file to list. Let's run this. Great. Now we're going to, looks like the first character is the letter. Yep, okay, so let's split this up into 4 line in L. Actions equal to line of 0 and val, let's just call it val, so you get int of line of 1 colon, print action val, and let's get rid of this print l. Cool, there's our values, great. So set actions, input values, north, south, east, west, left, right, forward. Great. Ship starts facing east. So let's that location and the ship's starting position. Great. So and then we've got let's just call it vec to represent our current direction. We're facing east, so that's if we assume x is positive going to the right. So we've got 1 for and 0 for the y value, and so now we need to handle each of these things. So if action equals n, if action equals s. So if it's n, then pos equal to util.vecadd of, so north is increasing the y value, so it's 0, 1, and then it's going to be our current position. Let's call that loc, just to match the way that I write other things. Okay, so that's north, and then we've got south is 0, -1, and then east and west are going to be very similar to this. East is going to be positive x, 0, y, and then this is west is going to be negative x and 0, y. Oh, I need to incorporate the values here. So this is actually going to be val. This is going to be -1 times val. This is going to be val -1 times val. Great. So now we've got all of those, and now we need the LRF. Ah, so that's why the direction matters. Okay, so the util is going to be underlined because I haven't fixed my linting, but L, LF at R, F, else, print. Oh no, what happened? Okay, so left, so let's think about how to shift this. So for left, I remember this this is possible to write just by shifting around the values. So this is vec is equal to vec of 1, vec of 0. So I know that one of these gets flipped to be negative, or maybe both of them. So when we're turning left, if we're facing right, then our vec of 0 is 1, and we want that to become our vec of 1. So that's fine. Does that always work? Yeah, so I'm just going to write these out really quick. So we've got 1, 0 should go to x should go to 0, 1, and then we've got 0, 1 should go to -1, 0, and then we've got -1, 0 should go to 0, -1. So I'm pretty sure it's just we add a negative, so this is already correct. And so this is negative vec of 1, -1 times. Great. And then similarly for right, we just kind of reverse the direction here. So now I think the -1 goes on the other side. Because now these arrows are reversed. So 0, -1 goes to -1, 0. Yeah, okay, I'm pretty happy with that. We might be wrong, but we'll see. Forward by the given value of in the direction of the ship is currently facing. Okay, so what we need to do here is say vec is, or sorry, we need to say loc is equal to util.vec add, and this is going to be loc, and the way we construct this vector is the direction that we're currently facing, and then we multiply it vec of 0 times value, and vec of 1 times value. Okay. And then at the end we just need to print loc, and then we also need to print the Manhattan distance, which is math.abs, or is it just abs? Abs of loc of 0 plus abs of loc of 1. Value is not defined. Val. Oops. I want 1058. Not the right answer. Dang it. Okay, so let's try this little tiny example. And let's change this to in2.txt and then run it. So now we've got 25. Uh-oh, that's not good. Oh, wait. I figured it out. The left and right stuff is not just a single left or a single right, it's by a number of degrees. Duh. Okay. So what we need to do here is say, I wonder if the left and right can be I don't see any negatives, so they're not going to mess with us too bad here. So num turns is equal to val divided by 90 for I in range num turns. We just do that all those times. And then same for right. Invalid syntax. I forgot a colon. Float cannot be. Dang it. I have to wrap it in int. There we go, got 25 again. So let's try it with the actual input. 1710. A 782. Did not do it very quick tonight. Okay, so before you can give the destination to the captain, how to move a waypoint, which is relative to the ship's position. Okay, so those four are still the same. L means rotate the waypoint around the ship's left, around the ship left. What? Wow. Okay, that's something. Okay. Okay. I understand, but this is about to get a little bit more complicated. So we're just going to start with what we have before, and now what we need to keep track of is loc ship, and or actually let's just say ship, ship, and then waypoint is equal to 10 units east and 1 unit north. 10, comma 1 relative to the ship. Waypoint is relative. Okay, so now north, south, east, west all mean move the waypoint only. So now this is going to be waypoint. Oops, over here. Okay, I'm happy with all those. That was the easy part. So now we've got to do something a little bit more complicated. So R90 rotates the waypoint around the ship clockwise 90 degrees, moving it. Wow. Okay, let's do the F part next, because I think that's going to be relatively simple. So the vector from the ship to the vec waypoint is equal to, oh, we no longer need this guy. So yeah, so I'm just going to call this vec now. So the vector from the ship to the waypoint is the waypoint's location minus the ship's location. So we've got waypoint of 0 minus ship of 0, waypoint of 1 minus ship of 1. Okay, so that's our vector. Lovely. So now we need to move there a bunch of times. So we need to apply that vector a whole bunch of times. So these only move the waypoint. This thing moves both of them. I think that keeping track of the you know what? I'm going to change something, the way that we're doing something, because instead of keeping track of the waypoint's absolute location, this number is going to represent the waypoint's location in relation to the ship. So we no longer need to do this calculation. And what we're going to do is we're going to just change the ship's ship's location, and the waypoint's location stays the same because we're just thinking about it in relation to the ship. So for I in range, and this is going to be val, because it's the number of times we're doing this, and then we're going to say ship is equal to util.vec add, and it's going to be waypoint, comma ship. Ship. Great. Okay. I'm happy with that now. Now we've got to figure out, actually, we're already done with left and right. This is done. The only difference is now it's waypoint instead of vec, because we wrote this the correct way the first time. Because it's still just rotation. It's just slightly different rotation. You're rotating around the point slightly differently. This might actually just be the answer, which famous last words, I know. Yeah, 324. Okay, so we did a lot better on part 2. Because I think purely because we didn't have to change this left and right thing at all, because we knew how to do this kind of rotation thing. This is a nice thing to memorize, just like, oh, if you're trying to take a vector and rotate it about 0, and you want to rotate it left, this is what you do. And if you want to rotate it right, this is what you do. This is the kind of thing that comes up again and again in these kinds of problems. So I'm kind of curious how fast people did. Wow, 4 minutes for both parts. Longest being 10, and I took about 15. Okay, and then 5 minutes for the first part. Me personally, I did it in 9 minutes and then 15:29, which I'm pretty happy about. Like I think that I did solve the second part quickly. The first part, I probably could have done a little bit faster, but it's just a matter of getting all the cases correct, and I probably could have written some utility functions to help out with that. Okay, so let's think about how we want to clean this up. I'm not sure I want to do much cleaning up right now, because like while there is a bunch of repeated code, it doesn't easily get rid of itself, other than just having this same for loop iterate and modify the values for both of them, both part 1 and part 2. So I might actually do that, but I don't need to do that on screen, because it's just gonna be a matter of combining the lines so that it calculates them both simultaneously. But anyway, thanks for watching. Hope you enjoyed.